So, students, welcome back to the second part of this lecture. So, in the last part of lecture I talked about the EM algorithm. EM algorithm means expectation maximization algorithm. Try to understand it. If you are not understanding, we will get back to you. Maybe the next lecture I will tell you some more things about that. And this algorithm is basically based on very simple thing. So, first you start with let me just explain to you again, then we can get back to it. So, what you do is start with some initial values, start let us say initial values, then you have a expectation step. I hope you understand what is expectation step. We expect the same values of the hidden variables will follow the same, right. I gave you a function h, that is what is your latent variable function. So, we expect the latent variables will follow the same function, that is what is the expectation step. Once you do the expectation steps, then you do the maximization step. There you are applying maximization. Remember that you basically find the maximum likelihood hypothesis. Maximum likelihood hypothesis tells you that if this h is not able to satisfy my prediction of the latent variables, how I maximize it. Basically, I calculate distance, the distance is maximization, and so that is what it is done. If it is convergence, fine. If it is not converging, fine, yes, it stops. If it is no, then again it goes back to the expectation. So, this is a iterative process, right. So, remember this. So, now we will go to the another important algorithm, which is called PCA, principal component analysis. PCA is something which is widely used in machine learning. So, therefore, we will not talk much details about, just to give you some idea. So, as the number of dimension of any problem increases, and number of possible combination of features also will increase exponentially. Obviously, if you have n dimensional things, suppose, and so you have number of features will also become exponentially high. I mean, it is talking about n dimensional means data sets. So, this makes computationally very difficult to obtain a representative sample of data, and also it is very expensive to perform tasks using clustering or classification. Many cases it has been found, like in case of some algorithms, they are very sensitive to number of dimensions. They need more data to achieve some level of accuracy or lower dimensional data. So, how do you address this problem? So, we will basically have a separate section of data preprocessing or data handling. There we are going to talk detail about this. This can be addressed simply by using feature engineering or feature selection, feature extractions, correct. That is what is called PCA. Many people call it Pearson component analysis, because it is discovered by Pearson. So, this popular technique will talk of detailed manner when you discuss data preprocessing techniques in later part of this course. So, now we move on to the deep learning. Okay. So, these are all machine learning algorithms, whatever we discussed, supervised, unsupervised, different kinds of algorithms. And we have spent quite a lot of lectures, almost like 10 lectures I spent on machine learning algorithm, because that is the heart of the course. Now, we will talk about deep learning algorithms. This is also very important for you to learn. As you know, I showed you this slide at the beginning of my lecture, that AI has two parts, machine learning and deep learning, right. And machines can understand and achieve specific goals simply by using these learning approaches. So, deep learning means you are using much better techniques to learn things, right. That is what is the meaning of deep learning from a layman point of view. But is it so? Well, what is deep learning? Deep learning mimics the intricate neural networks of a human brain. Remember this. we process data much intelligently, that is the human brain is. So, can I mimic this intricate neural network? That is what is deep learning does. In this process, it enables computers to autonomously discover patterns. It does not require any kind of other kind of things, help or something. It can autonomously discover patterns, right. For us, I told you, right, if I childhood I have seen a cycle and a car, and then I can immediately differentiate when I see a new cycle or new car. That is called autonomous discovery of patterns. Many cases even much better decision making things can be done, like it can make decision from vast amount of unstructured data. Unstructured can be text also, right. I talked about it. It can be text also, and that is why it is used in various domains like computer vision, natural language processing, or what is called NLP, healthcare diagnostics. Not even that, even autonomous driving also possible. You probably heard of some cars made by companies like Google, others, which can automatically drive, right. So, deep learning uses this technology. So, it is typically based on artificial neural network structure, but it uses more integrated neural networks. And it has, in ENN we have talked about, it has many layers of interconnected nodes, and they are called neurons, and that can work together, right. That is what is done. So, specifically it is a branch of machine learning that is based on ANN network architecture, and this uses a layer of interconnected neurons. So, in a fully connected neural network, there is an input layer and there is also an output layer, and there will be many hidden layers. So, in a deep learning you can have hundreds of thousands of hidden layers possible. That is what happened in case of our human brain. Integrate neural network connections can do that. So, in a nutshell, so what is the difference between machine learning and deep learning? Machine learning is apply statistical algorithm to learn the hidden patterns and relationship data sets, but deep learning uses artificial neural network architecture to learn these hidden patterns and relationships. Remember this. Machine learning can work on smaller number of data sets, but deep learning requires large data sets compared to machine learning. So, therefore, machine learning is good for low level task, whatever you do, but it is not low level task. Lot of tasks we do in machine learning basically a high level task, and they are very good for complex tasks like deep learning, because it is handling large amount of data, is very good for image processing or even natural language processes. There are many natural languages. If you want to, many of you are actually texting on your messenger services, and words keep coming in your fingers. You do not have to search it, right. How does it happen? It happens because of the use of deep learning. You will see that when you are using messaging, sometimes you type one word, automatically many others pop up and you select, right. That uses this deep learning methodology, because it can actually do this NLP or natural language processing very nicely. It can even use grammar correctly and allow you to write a sentence. Many times you use that. I know many of you write email in Google, Gmail, you can see that I write a text, automatically some more things words comes to complete the sentence. So, they can actually do this kind of analysis. This is a part of deep learning actually, and it takes little time to learn, but it is very good methods. So, what happened? A model here in machine learning is created by relevant features which are manually extracted from the images to detect the object of an object in the image, right. But in case of deep learning, relevant features are automatically extracted. You do not have to do manually from the images. It is like an end to end learning process. That is what human does. Human, any small kid or something started learning something, it will be end to end learning. It is not like I learn bits and pieces. I learn the whole process. If I have to walk from this room to other room, so I have to find the door and reach the other room, everything is learned, but machine learning uses bits and pieces to do that, and that is why it is less complex, easy to interpret results. But deep learning, because it uses artificial neural network framework, it is more complex. Sometimes people think it is like a black box, obviously, because many of these passenger techniques, whatever you see, they use as a black box kind of things, and that is why results are not easy to explain. And machine learning requires high performance computing with GPU, but deep learning, machine learning can be done in CPUs or something. So, what are these applications machine learning has? First, like to understand. First important application is a computer vision. It can detect and recognize an object, it can classify images, it can segment images. So, in future technology will be like that. If you go to airport and you already have given all the informations and you stand in front of the gate, there will be no security, you can enter because of the use of computer vision. They will detect from your image of your face that you are the right person or not. They don't need to, you don't need to show any ID card or anything. That is what is the ultimate things computer vision can do. It can also use natural language processing like automated text generation, I talked about it few minutes back. It can do language translation, Google translation does that, right. You type something in English, it will convert into some Indian languages, some other languages, or you do not know Chinese, you can convert to English. This is how this NLP works. NLP works using a deep learning methodology. It can do sentiment analysis also, whether you read a text, whether text is talking about laugh, talking about cry, talking about some other sentiments, it can easily detect. So, it is so powerful, and obviously it can do speech recognition, which is not much higher level, but it can do even much better speech recognitions. There is something else also it can do, which we will talk now. It is called reinforced learning, and this is used in game playing robotics control systems. What is that reinforced learning? Okay. So, you have learned about supervised and unsupervised learning. So, let us talk about that, about reinforced learning. Supervised learning means you have a predictive model based on both input as well as the output data. But in case of unsupervised learning, you have only input and you have to group the data and interpret. That you have learned in the last 10 lectures or so. But what is that unsupervised reinforcement learning? It is a machine learning technique which agent learns to make decisions. Remember this. In an environment to maximize the reward signal, you have an agent. Like when you play games, somebody is playing for you in the games actually, and you are playing the joysticks. You are playing with the joysticks. So, that is like an agent playing something, and that allows you to make decisions in an environment to maximize the reward signal. Reward signal means you want to win the game. There are different levels of the game. Once you start level 1, level 0, level 1, level 2, level 3, level 4, right. So, the agent does actually everything for on your behalf, but you are playing with the agent, do not worry, that is what it is. So, agent interacts with the environment by taking actions and observing the results. Remember this is very important. The agent actually interacts with the environment by taking actions and observing the results rewards. Deep learning can be used to learn policies even, a set of actions that maximizes the cumulative reward over time. There are many deep learning methods, deep cube networks, deep deterministic policy gradient, DDPG, many others are used to do that. So, I hope I am clear, right. Compared to unsupervised learning, this is a different, this is here you are using a agent to do that. Okay. So, let me explain to you a much better way. What is it? I wrote somewhere, let me see. So, this is agent based learning is kind of allows you to create games and robotics. A robot you can control that, and you can even control the control systems. So, now the question is, since deep learning is based on artificial neural network, or how our brain works, these slides I have shown you earlier also. So, a brain is nothing but a parallel computational information processing system. Okay. It is like a parallel information system. It has a large number of networks of elements, which is nothing but a neuron. It actually 10 billion neurons are there, and they parallelly process the data. How does it do? So, this is a neuron typically, this one I shown you, right. You see these are the dendrites, which are nothing but input, they collect the signals. Okay. If you are putting the hot objects on a screen, immediately nerves will take the signal from the temperature is rising, right, and then it gives the signal to the body, or that is the nucleus. It processes that signal, and once it processes signal, it will be sent via synaptic link, and then it goes to the action for any output. And this output of one neuron is input to the other neuron. That is what is called parallel processing. So, one neuron will process it data, give an output, that output will be used by the another neuron of the second neuron as an input and process further. So, if it processes that way, so what will happen? Your quality of output will slowly improve. So, you will be immediately taking your hands off from the hot objects, that is what it does. So, this level of intelligence is what is done by the parallel processing of the neurons in the human body, and that is why we talk about multi-layer perceptrons, okay, perceptrons. These humans have the ability to identify patterns very easily, right. So, whenever artificial neural networks computer systems intend to imitate that human learning capability, we have to create this complex architecture like we have in your brain, right. That is what you have to do, because then only we can actually make a better decision making capability, or better decision can be made easily with much faster, much higher accuracy. So, a perceptron is simply a binary classification algorithm, remember this. So, that means it can take either 0 or 1, it can take 0 means negative, 1 means positive, right. So, unlike classification algorithm, this is perceptron is modeled using concept known as essential unit of human brain or neuron, and perceptron is simple, basically nothing but a simple learning machine, and it takes few inputs, each of which has a weight to signify how important that input is, we will talk about it, and then generate an output is yes or no. However, you can combine with other perceptrons, it can form an artificial neural network, right. You can combine many those kind of things. So, let me go back here, yes, this is what it is, a biological neuron as you see here. So, you have inputs here, we put weights on that each inputs, correct. So, that is what it is, you see there W0 x0, W1 x1, W2 x0, weights are placed depending importance of a particular input, okay, which one is more important than the other. And once you do that, then you sum it over and do some kind of a analysis, that is what a function is, apply certain function on the summation, summation is giving all the output together, right, all the input together, sorry, and this sum it over and then applied, then actually used by the activation functions to give an output. Activation function, I told you that can be anything, it can be logarithmic functions, it can be exponential functions, depending on your use, your need. So, that is what is done. Let us talk about here. So, these are the inputs you see here, and then you put some weights and then sum it over. So, after you weights or sum it over, what you do? You put this to a activation function or transfer function, you can see fx, that gives you output. So, now we can make many layers between that, you can have several activation functions which can operate on these kind of aspects, right. So, I can see here this input, the weights, summation, activation functions, and then this is giving you some sum it over again, and then output is obtained. That is what is artificial neural network does. So, in a multi-layer perceptron, is nothing but network is formed by teaming up perceptrons with additional ones. Basically, they are stacked like several layers. You can see here several hidden layers are stacked, other input output, and each perceptron in the first layer on the left is nothing but input. It sends its output to all the perceptrons in the second layer, and so on. There will be many such layers one by one, and do that. And remember, each layer this thing is done, this weights, activation, everything is done. So, output of each layer is input of the next layer. That is how this parallel processing is done. That is how this parallel processing can be done like a brain. And this is a 3-layer network. We have input, hidden one hidden layer, and one output. You can see here, and you can have 4 more layers. That is what is called deep neural network or deep learning network. And what is the difference between this and normal neural network? I talked about it earlier also. Difference is that MLP and neural network is that it is basically decision making functions are different. Okay. And neural network that evolved from MLPs other than activation functions can be used more than 0 to 1, it can use -1, +1 also, many other variables. And how does it work? Let us talk about a little bit. First is it takes the inputs, multiplies by the weights, compute their sum. Why do you do that? Because weights allow you to perceptrons to evaluate the relative importance of each outputs, and neural network algorithms learn by discovering better and better weights as a result of more accurate predictions. Okay, that is why you have to do different kinds of weights. And then you can tune the weights also, which is very common, that is what is done in back propagation I discussed with. You can add a bias factor, okay, also like you can number 1 multiplied by weights, and that is a bias. You can add a bias to it. Then after you add it up, you can put a bias, and this is technical steps that make it possible to move to the activation function curve up and down. Bias will allow the activation function go up and down, left and right on the curve, right, and that makes you to fine tune the numerical outputs or numerical values of these weights. Then you do the activation function, feed the sum through this activation function. Activation function maps the input values to the required output values. The input values can be 0 and 1, or is it 1 and 100 between. Outputs can be 0 and 1. That is what is done. And then certain properties of activation function, especially it is a non-linear, it must be non-linear. You know, all our decision making processes in brain is basically non-linear, it is not linear. Human brain is very complex network, and then you get an output by that way. So, in a multi-layer perceptron, output of one layer perceptron is the input to the next layer. This I have been telling you again and again. So, important aspects which we will discuss in the next class. We already discussed about back propagation, we will talk about hyperparameters, tuning hyperparameters, and we will talk about some other advanced structures also. So, let me stop here. So, this is a very simple descriptions of deep learning. We will move into details of that in the next 2-3 lectures and discuss their basic aspects. Thank you.